Let's move on to section 5 here. And this time we're going to look at point slope form of the equation of a line. Now this one's a little bit tricky. When you are given the y-intercept, when we have a formula, we could find slope using the slope-intercept formula is terrific. What happens if the one and only point that you know doesn't happen to be the y-intercept? That's why we need point slope form. We can always use this if we know the coordinates of one point and we are given the slope. You can use point slope form. See how that works? All right, I got to be careful here with these subscripts. We've got an x sub 1 over here in parentheses, and we have a y sub 1 over there. These refer to the y sub 1 means the y coordinate of the given point. The x sub 1 refers to the x coordinate of the given point, and of course m is slope. Now again, let's not get these mixed up here. The fact that the y sub 1 is not the same thing as the y. The x sub 1 is not the same thing as the x. In the end, we want an equation that's still written in terms of x and y. So for those two variables, we're never ever going to substitute. So for the 5 different components of this here, we are going to substitute things for the y coordinate of the given point, the slope, and the x coordinate of the given point. Now again, this is going to be a situation where we are given an ordered pair. That's what we substitute for x sub 1 and y sub 1. And then, of course, we substitute the slope in place of the variable m. If we're, say, given an equation in point slope form, it's not that tough to graph that line that way. We start with the ordered pair. We plot that point on the graph. And then we can use the slope, like we did before, as a set of directions. But I'm going to insist here that we plot 2 points. Let's make sure that we're going in the right direction. All right, so they're giving us, this kind of sneaks in down at the bottom here. Here is an equation in slope-intercept form. It says y minus 4 equals negative 2 times the quantity x plus 3. Well, that means our slope is negative 2, which of course, again, we looked at this before. Turn that into a fraction. So negative 2 over positive 1. Now, here's the tricky part. We said y minus 4 is where it started here. So that means the y coordinate of our given point is 4. Remember, the equation says we're supposed to take y minus y sub 1. It also says in the parentheses we have to take x minus x sub 1, But here it doesn't say x minus 3, it says x plus 3. Well, how did that change from an addition, sorry, from the subtraction into an addition? With a negative 3. Because again, if you had x minus negative 3, you would simplify that into x plus 3. So once we can read the equation here, once we can pull from it the slope and the coordinates of a point, that's enough for us to graph it. So we go ahead and plot the point negative 3, 4. Remember, if the x is negative, that means 1, 2, 3 spaces left. The y coordinate is positive, so we go up 1, 2, 3, 4. Here's the given point graphed on our grid. Now the slope is negative 2 over 1. So that means I could either come down 2 spaces and go 1 to the right. So that'll put me at negative 2, 2. Or if I wanted to go up 2 spaces, then I would have to go 1 to the left. So that'll put me at negative 4, 6. Then we can draw our line, and there's the graph. We did not put it into slope-intercept form. We could figure out what the intercept is after we graph it. Oh, wait, what happens if we're supposed to use point-slope form and they didn't give us the slope? Okay. This happens when we're given 2 points. First of all, we need to know the slope, regardless if it's point slope or slope intercept. So we start there by using our slope formula to calculate. Once we found the slope, here's the key thing. If that line goes through both of those points that they gave us, we can use either one in the point slope equation. All right, so let's do an example here. Write an equation in point slope form of the line that goes through 0, 9, and 3, negative 3. So step 1 is we need the slope formula. So again, remember, we're going to match up x with x. We're going to match up y with y, and we're never ever going to put together an x and a y. So say second minus the first, careful of your negatives. Negative 3 minus 9 over 3 minus 0. Well, negative 3 minus 9 is the same thing as saying negative 3 plus negative 9. 3 minus 0 is just 3. That denominator's easy. Negative 3 and negative 9, if both of them are negative, our answer is negative. 3 plus 9 is 12. Negative 12 over 3 is negative 4. Now we can use either of these. We could write, say, the first one, y minus 9 equals the slope we just found, negative 4 times x minus 0. Or, again, the direction said write an equation in point slope form. You don't have to use the first one. Y minus, careful, negative 3. See what I did there? Subtracting the negative turns that into an addition. You should always simplify it. Negative 4 times x minus 3. Now, sometimes we would prefer to have the equation in slope-intercept form. So if you're given a point and you know the slope, you're asked to write it in slope-intercept form. We first of all put it in point slope form. and then convert. Okay, so this is a two-part process here. Given 0.54 and the slope of 2/5, write an equation in point-slope form first, then slope-intercept form. Okay, so we're going to take y minus, again, the y coordinate of our given point is 4, is equal to, they said the slope was 2/5 times x minus the x coordinate of our given point is 5. So here's the equation of this line in point-slope form. Now, if you think back to, we talked about slope-intercept form, looks like y equals mx plus b. Notice here, in point-slope form, we have 1, 2, 3, 4, 5 different parts to it here. Whereas in slope-intercept, there's only 3 terms. So the first thing we're going to need to do to get it from point-slope form into slope-intercept is distribute. Let's leave the y minus 4 alone for the moment. 2/5 times x is, well, going to be 2/5 x, and that looks very similar to what we need here. And now we're going to take 2/5 times -5. Positive times a negative is negative. 10/5, in other words, it's just 2. So that looks better in the fact that we've gotten rid of the parentheses. Instead of 5 parts, we only have 4 parts now, but we're supposed to get it down to 3 parts. Notice, y is all by itself. And here, I don't have y all by itself. I need to fix that by adding 4 to both sides. So we'll get y is equal to 2/5 x. -2 plus 4 is 2. And there's the equation in slope-intercept form. Now again, you might be faced with the challenge of taking an equation of a line, putting it into slope-intercept form, just given 2 points. Well, we're going to start the same way we did with the previous example. We're going to calculate the slope. We're going to put it into point-slope form, and then convert it into slope-intercept. Given the points 2, -2, and -4 is 6, write an equation in point-slope form first, and then we'll simplify it into slope-intercept form. So part 1 is find the slope. So I could say for the y's, 6 minus -2 over, for the x's, -4 minus 2. For the numerator, subtracting a negative is the same thing as adding a positive. 6 plus 2 is 8. In my denominator, -4 minus 2 is the same thing as -4 plus -2. So that'll be -6. That should reduce down to -4/3. Pick a point. Doesn't really matter. If this line goes through both of those points, we should get the same equation either way. Say I'm going to use the first one because those numbers are smaller. So y minus negative 2 is equal to negative 4/3 times x minus 2. Well, over here on the left side, I can rewrite that as plus 2. Over here on the right, I'm going to distribute. So negative 4/3 x. Negative times negative is positive. And this is now 8/3. And then to get it into slope-intercept form, I need to get y all by itself. So that means I need to subtract 2. Now, it might be helpful here. I have to take 8/3 and subtract 2. I need a common denominator because, again, a nice whole number there can be thought of as having a denominator of 1. Negative 2 over 1 would be the same thing as negative 6 over 3. And now when I add 8/3 plus negative 6/3, that'll give me still plus 2/3. Not pretty, but it's accurate. Now let me show you how this works with either point. Okay, so again, I'm going to use the slope of negative 4/3, but I'm going to use the second point this time. So I'll take y minus 6 is equal to negative 4/3 times x minus negative 4. Now, in my mind, the first thing I want to do here, leave that y minus 6 alone. Before I even distribute, I want to simplify. Subtracting negative 4 is the same thing as adding 4. Then I want to distribute. And now I need to add 6 to both sides. Which, again, I'm going to need common denominators with negative 16/3 plus 6 over 1 is the same thing as 18/3. Negative 16 plus 18 will give me positive 2/3. And those two equations are the exact same thing. So it really doesn't matter. Once you find the slope, again, that has to be the first thing that you do, is calculate the slope. It really doesn't matter if you're given 2 points, which one you use. We should be able to come up with the same equation either way.